I'm going to talk now about two of the most extended application of the Internet of Things and one of our strongest product lines, air quality and noise monitoring. Most of the cities that want to become a smart city have as one of the main targets the monitoring of the air quality of the city and also the noise levels. Both environmental and noise pollution are two very critical aspects in many cities, especially on those with a high population, where high density of traffic causes a high level of pollution on the air and also high noise levels. According to the World Health Organization, excessive noise seriously harms human health in many ways and interferes also with people's daily activities at school, at work, at home, and also during the leisure time. It can disturb sleep, it can cause cardiovascular and psychological damages, it can reduce the performance at work and provoke also negative responses and changes on the social behavior of the people. Regarding the pollution on the air, this is caused normally by heavy car traffic, and it's very known, and it's a major threat to health and also to climate. The effects on the climate, it's about 5.5 million premature deaths every year, according also to the World Health Organization, and resulting on strokes, on heart diseases, on chronic pulmonary diseases, on lung cancer, on respiratory infections, so many health damages. More than 80% of the people living in urban areas are exposed to air quality levels that exceed the levels given by the World Health Organization. For these reasons, most of the cities with the smart initiatives are monitoring the air quality and noise levels on critical parts of the city. Our solution for this is the product Smart Cities Pro, and I'm gonna show you now based on our product catalog. On page 3, you can see the different options for our products, right? So first would be the kits ready for the marketplace, the plug and sense line encapsulated, and the OEM. As the most extended probably would be the plug and sense models. I'm gonna cover this one. So here in this page 30, you can see an overview of the product, also how it's mounted, the certification, the easy maintenance that it has, the installation, and so on. So basic characteristics. Here, you can see how you configure the product. Each plug and sense device has 6 different sockets, named by A, B, C, D, E, and F. And each socket supports different kind of sensors. So you can select a maximum of 6 if each one is in a different socket, as you're gonna see. If we go to models, you see the different options, right? So we're gonna cover now the Smart Cities Pro. Here you can see all the sensors that it supports: noise, particles, different gases, temperature, humidity, pressure, luminosity, and ultrasound. So clicking on this, we go directly to the product page. And here you can see the different connectivity options, okay? Depending on the region of the world that you are, you would be selecting one or the other. There are some with no differentiation, for example, Wi-Fi, but there are some, for example, XP with X168, which is for European and alike frequency bands, or 900, where we have the US or the Brazilian or the Australian standards. We have basically XP 802.15.4 or 686 or 900. This is radio frequency protocols. We have the Wi-Fi option, the 4G, according to the different main region models, LoRaWAN, and Sigfox. So first of all would be for you to select which is the connectivity for this project. And then in the page after, you can see the different sensors available. The most typical parameters on air quality index on the city would be carbon monoxide, so CO, ozone, NO or NO2, and SO2, the sulfur dioxide. Those are the most extended ones, and the dust particles, which gives the output as 3 different diameters of particles, 1, 2.5, and 10. Then you can complement the solution if there are sockets available with luminosity to detect the light levels and the ultrasound to measure distances. Important remark, all the calibrated gases sensors need the temperature sensor. They need the temperature value so that they are accurate and they can correct the measurement. So anytime you require any of those sensors, three different possibilities, you need to select the temperature sensor on one of the free sockets, so A or E. Then once we have all the sensors selected, we would go to different power options, okay? Now the battery, the rechargeable battery is included with the power, with the device, with the plug and sense device. And now we only need to select if we want to have the external solar panel, that would be the item and the reference, or if we just need the simple outdoors USB cable to be put outdoors, the socket is the power socket, or just in the powered by USB. If it's gonna be installed indoors, you won't need the USB, the outdoors USB cable. You would just need this reference, which comes with the long USB cable and the international plug adapter. Then, depending on the communication protocol that you have selected, you might also need Libelium to send the data to a certain cloud. So here's the typical configuration for Libelium. This would be the different WAS mode plug and sense devices sending the information to the gateway, and Libelium can send the data to the internet, basically towards Ethernet or 4G. Here you can see the main features of the gateway. Here again, a scheme of how the devices plug and send information to Libelium and Libelium to the cloud. Here the different software platforms, cloud platforms, where you can connect. And here the different models, depending on the radio protocol that it's receiving. And all of them have 4G and Ethernet as a communication protocol to send the data to the internet. So here you would select the model depending on the region you are and the communication protocol that the WAS mode plug and sense has. Now I'm going to show you different end-to-end solutions that include our hardware, plug and sense devices, sensors, and gateways eventually, and software application that some of our partners have developed in the scenario of the smart cities, which normally include environmental monitoring and noise monitoring. Here's our marketplace. Probably you're familiar with it already. And here you can filter the kits by the vertical. So if we are talking about smart cities, we would go here and we would see how many different solutions that we have available. All of them have similar but different bills of materials. Let's say if you position the mouse here, you would see, for example, if you're familiar with technology, you will see that this is a noise sensor. So there would be a noise monitoring device, and those are calibrated gas sensors and a gateway. So here, by just pushing here, you can see that it includes, this solution kit includes like 3 different plug and sense devices, a weather station with the weather monitoring sensor. And you can see, for example, this one, if you're familiar, you can see that this is a multi-tech gateway. So this is LoRaWAN. Here you can see also the description. And if you click on any of them, you will see general description of the device, of the sensors, and also the software application. Here you can get into detail about the communication protocol, about the software, also the free trial period. All of them, or most of the solution kits, include a free trial period on the software platform, and here is described. Here you can see also a description about the LoRa, in this case, the LoRa connectivity, or when it's 4G or other. And you can see here the bill of material, all the sensors that includes. In this case, also includes SIM card of Symphony Mobile, and also links to the related technical documentation. Here you can access a quick start guide. Once you have it, it will help you to easily configure and set up the devices, and also related technical documentation about the gateway, about the plug and sense. It includes also technical consultancy, so 2 hours on any kind of issue that you want to, or adapt the sensor kits to any other application, and the different options. If we go back, again, smart cities, you can see, for example, this other one by Cumulosity, different software application, different sensors. So you can choose among many different kits the solution that adapts more to your project or case. Now I would like to show you some of our success stories regarding environmental monitoring and noise level control as well. So if we are in our website, libelium.com, and the section case studies, you can see all of them, but you can also filter, okay, by type. So either environment or cities. If we go to cities, it's a bit more general. We can see different kind of projects that some of our partners have completed with our technology. Let's see a couple of them different. This project in Tilburg, Netherlands, done by Ericsson. You can see most of the relevant information. What are the sensors deployed? How the devices were installed? This one will consist on different devices, noise monitoring, environmental monitoring, dust particles, even also some water quality sensors. All of them are sending the data to a gateway, and the gateway is connected to the software platform, in this case, Ericsson One. I'm going to show you other case study, very related with noise monitoring. This is the one done in the airport of Athens in Greece by our partner Ex Machina. And this one was monitoring noise and also environmental values using protocol LoRaWAN. And with this application, they're able to show both the air quality levels and the reduced noise impact that the airport has. Even they were able to locate planes related to the noise levels, also by the installation of several microphones on the different parts of the airport. Here you can see some screenshots of the software application. The third project I wanted to show you, it's about the environmental monitoring, but this particular one is very interesting because it was done in vehicles, in mobile units. So our partner Sensis in the UK installed the devices on a cage here on top of the van, and they have here the plug and sense device with different environmental and dust particle sensors. And in this way, they were able to map the pollution of the city on real time. So they were able to acquire the data of the pollution levels and do a mapping, as you can see in this image, associated with the GPS position. So pollution levels with GPS location on real time. And in this way, the city is able to know in which parts of the city are more polluted at what time. Here in this, you can see more information about the project.